Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. As you know that in last lecture we have discussed the two different forms of mechanisms of the beta elimination reactions. Now we will discuss in detail in this lecture. So there are two types of mechanisms of beta elimination reactions: E2 mechanism and E1 mechanism. As you know, in E2 reaction, as you know that in E2 mechanism, the base will take the proton and this bromine or nucleophile will remove in the single step. So in the single transition state, this bond will break down and this bond will break down and this bond will make, and you will get the double bond in a single step. So the rate of reaction will depend upon the concentration of both the reactant and also the concentration of the base. Due to this reason, this reaction is called the bimolecular elimination reaction. However, in case of E1 mechanism, what happens? So what happens in this case? The first carbocation is formed, the leaving group left the first, and then the second group will left, and you will get double bond or nucleophile will attach to the nucleophilic substitution reaction. So the rate of reaction in this case, the rate of reaction will only depend upon the concentration of the substrate, CH2, CMA2Br. Now the question is, who will decide and how we will decide that the reaction is E2 or E1? So there are two methods to determine that either the reaction takes place through the E2 mechanism or reaction takes place through E1 mechanism. I will write both the methods one by one. In the first method, if we carry out the reaction with, first method is called primary kinetic isotopic effect. In primary kinetic isotopic effect, if you take this reagent, so what we are doing? We are replacing the CH bond with a CD bond. If we replace this H bond with the C bond, instead of CH bond, here we have taken the CD bond. So if the reaction takes place and the rate of reaction is similar, it means that the rate of reaction is, this bond is not broken, the rate determinant step, and the reaction will be E1. If the rate of reaction is unchanged, then the reaction takes place in an even mechanism. However, if the reaction rate is been changed, because when we change H from D, it has more mass as compared to H, so rate of reaction will be changed. So it means that the broken of this this carbon hydrogen bond is broken in the rate determinant step. No change in rate, it means the reaction is even. It means that this bond is not broken in the rate determinant step. But if there is change in rate, then this reaction is E2. This is the first method to check when the reaction takes place E2 mechanism or reaction takes place through E1 mechanism. We change this carbon hydrogen bond to carbon D bond. We take deuterium instead of protium, and when we carry out the reaction and measure the rate of the reaction, if the rate of reaction of both the reactants is same, there is no change in the rate, then it means the reaction takes place through E1. And if there is a change in the rate of reaction, then this bond is broken in a rate determinant step, and this chain reaction is a E2 by molecular elimination. Okay, we have another method to check whether reaction takes place through E2 mechanism or E1 mechanism. Suppose we are carrying out a reaction in the presence of ethanol, then because ethanol is used as a solvent, so ethanol will not be introduced into the rate equation because ethanol remains constant. So the rate equation will be K MECH2 CME2Br. So how we can determine that this reaction is E1 or E2? Because the rate only contains this reagent. The rate equation will not show the ethanol because ethanol is used as a solvent and it remains almost constant. Now the method is to use a stronger base. We will use ethoxide instead of ethanol. In ethanol solvent, we will introduce ethoxide, and because ethoxide is a stronger base, it will change the rate of reaction. If it changes the rate of reaction, it means the reaction is E2, and if the addition of ethoxide will not change the rate of reaction, it means the rate is E1. So by introducing the ethoxide as a stronger base, if it changes the rate of reaction, it means the rate contains the two molecules and it is E2. But if the presence of ethoxide ion will not change the rate of reaction, it means the reaction is E1.